So here we are looking at the reaction of our group 1 metals with water. We're going to start with lithium. It's at the top of group 1. You can see that lithium is, like all the other group 1 metals, is stored under oil. And that's because even if it was in a container that was exposed to the air, it could react with the oxygen in the air. So I'm going to cut a little bit off. You'll notice that the surface of lithium is very dull, but when I cut into it, when it's freshly cut, it's shiny. So that's one of the properties of our group 1 metals, that they're dull on the surface, but when they're freshly cut, I'll cut another bit for you to see, then they are shiny. Now, most of them are easy to cut. Lithium's a little bit harder, but we should get there. There we go. And you can see it's nice and shiny on the surface. But it will get dull very quickly, and that's because it's reacting with the oxygen in the air. So I'll cut ourselves a small enough bit to react with the water. So a couple of safety features I want you to notice around here before we do our experiment, and you may have to quote these in your exams. So first of all, you'll see that I haven't been handling my metal directly. I've been using tongs, and I also have gloves on as well. You can see that we've got a safety screen around here, and that's to protect anybody who was observing this reaction. We've got safety glasses on as well, and we're using a very small piece of metal in a large volume of water. If you think if we were to do this in a boiling tube, the reaction, it could be so vigorous that it could smash the boiling tube. So that's another safety feature too. And you can see that I've got the bench protected with heat-proof mats as well. So I'm going to set this lithium off to the side, and let's see it reacting with water. So you can see now it's starting to react with the water. Something slightly strange you might notice is that the piece of metal is floating. With most metals we expect them to be so dense, so heavy, that they would sink to the bottom of water, but you can see that these group 1 metals will all actually float, and that's because they have a low density. It's fizzing, it's giving off a colourless gas, that's hydrogen. It's floating on the surface, it's moving across the surface, so it's not staying still. Eventually that little piece of lithium is going to disappear, and what we will be left with is a colourless solution. And although we are doing this on such a large scale, you'll not notice much heat given off. This water doesn't feel warm because it is cold water, but actually this reaction is giving off a lot of heat. So your final observation is that heat is released. So you can write as many of those as you remember into your notes, but I'll go through them afterwards as well. So now the reaction's finished, you can see that we're left with a colourless solution. Okay, let's move on to sodium. And again, I will not handle it directly. Again, stored under oil, you can see the oil dripping off there. I'm just going to give it a quick dry. I want the excess oil off. Because as you know, oil and water do not mix, and so it wouldn't react just as well with the water. Okay. So again, I want to be cutting off a small amount. That's one of my safety features, that I'm only using a small amount. Again, see how shiny that is when we freshly cut it, but it goes dull so quickly. If I cut another wee bit off, you'll see that the shiny surface, but it dullens very quickly. So we'll put the lid on this just to be totally safe and get that out of the way. And then we'll put our small amount into water. So sodium's the next metal down in our group 1 after lithium. So let's see how its reaction compares. So you should see something different already, that our piece of sodium has melted into a shiny grey sphere. So that's slightly different than lithium. Lithium didn't do that. So it's melted into a shiny grey sphere. Again, it's fizzing. You can see it's floating on the surface. It's moving across the surface. And what you should see is that it's reacting a little bit more quickly than with the lithium. So again, it's moving across the surface. Eventually that little piece of sodium will disappear, and what we'll be left with is a colourless solution. And again, your final observation is that heat will be released in this reaction, Again, it's not that my water's getting super hot here, but that's because we've got a large amount of water and only a small piece of sodium. But this reaction produces heat. So fizzing floats on the surface, moves across the surface, metal disappears, colourless solution forms, and heat is released. And you can see our ball is getting very small now, and that's the reaction finished. So we have one more metal that we're going to look at together, and that's potassium. So let's cut the piece of potassium first of all. Again, you can see it's very dull on the surface, but when we cut it, you should see that it's nice and shiny. This one, we'll cut a couple of pieces off. We'll maybe do this a couple of times, but we want to make sure that this is nice and small because this is quite a reactive metal. Okay, so again, nice and shiny on the surface when we cut it, but it dullens down very quickly. So we'll cut those pieces off in case we want to see this again. But we'll put the excess back in the bottle just to be safe. Okay, so we'll get that out of the way and let's have a look at our reaction of potassium with water. Okay, so you can see this is different again in that we are forming the shiny grey sphere just with sodium, as with sodium. I'll just tilt this bowl a wee bit to try and get that last wee bit to react. Okay, but what you should notice is that is much more reactive. Even though this piece of metal is reacting with water, we're seeing that it actually burns with a flame. Let's see it again there. Okay, so you can see it ignites and it forms that lovely lilac flame. And towards the end you get that crackling sound as well. So again, you've got all the same observations as with lithium and sodium. So it's fizzing, it's floating on the surface, it's moving across the surface, the metal disappears, a colourless solution formed, and heat is released. But the differences here are that it burns with a lilac flame, and listen out for the crackling sounds as well. Okay, so a nice crackling sound, and there we got a nice good explosion at the end, and that is just basically your hydrogen exploding. So remember, these reactions produce hydrogen, and if you've got a flame there, we've got essentially a hydrogen pop. So that's a little bit different with potassium. You've got your lilac flame and your small explosion at the end. One last thing I'm going to do is that you'll note with all of these reactions we produced a colourless solution, and that's what your observation should be. But sometimes you're asked the following question: if we were to add universal indicator to this solution, what colour would it turn? They could ask you it that way, or they could ask you why it turns the colour it does. So this was in your acids, bases and salts topic about the pH scale and the use of universal indicator. We know that a neutral solution of, for example, of water would turn universal indicator green. That indicates a neutral solution. But if I add some universal indicator here, you can see that my solution turns purple. Have a think what that means. It means that the solution is a strong alkali. So the reaction of our alkali metals with water produces an alkaline solution. So if you were asked, why does universal indicator turn purple in the solution after this reaction happens? Well, it shows us that the solution produced is alkaline. And that makes sense because our group 1 metals are called alkali metals, and they produce an alkaline solution when they are reacted with water. So if you think what we've produced with all our metals here, a metal reacts with water to form a metal hydroxide solution and hydrogen. So the gas being given off during the reaction was hydrogen, and what we've got here is a solution of our metal hydroxides. It will be a mixture because we've done it all in one trough of water, a mixture of lithium hydroxide, sodium hydroxide and potassium hydroxide. And those solutions are alkaline, and that's why they've turned universal indicator purple.